Hi, I'm Lisa Moffitt. The intention of my talk is to really make the case for the value of using environmental models as teaching tools by showing a series of exemplary projects from a studio that I taught that was cited in Bath, UK. So what are environmental models? I'm using the term environmental models to refer to physical apparatuses such as wind tunnels that visually and qualitatively and quantitatively make visible airflow patterns in particular. This is an image of a wind tunnel. These practices are largely obsolete now, and students tend to rely when thinking about environmental exchange on either static environmental diagrams, such as the one that you see on the left, or computational techniques, dynamic simulations, such as computational fluid dynamics. And what my research is trying to do, and this research is translated into teaching, is to speculate about ways that environmental models might be used not only as modes of environmental verification, but also as multi-scalar design tools. So I'm just going to show you a series of my own prototypes of 3 different kinds of environmental models that were used in the studio as well. So the first type are wind tunnels, which most of you would be familiar with. The conventional way for visualizing airflow in a wind tunnel is by using smoke, but I've also developed techniques for visualizing airflow as a series of sort of moving vectors. The second technique is using water tables, which use a thin sheet of water to make airflow visible, also making pressure-induced airflow associated with cross-ventilation visible. And you can see a few tests of the challenges of doing that, which really reside in making a flat, even surface of visible streamlines. The third technique that we used were called filling tanks. This is a mechanical engineering technique that makes buoyancy-induced airflow visible. And the way that technique works is that salt water is introduced into a plexiglass model submerged within an aquarium, and this enables visualization of either the introduction of cold air into a warmer environment, or when the model image is flipped, the introduction of warm air into a colder environment. So I've written a bit about these. You can look at those publications if you're interested. And now I'm going to focus on how teaching was used as a way of expanding some insights that were cultivated through my own research. So I taught a 1-year studio called The Streamlines, Vortices, and Plumes of the Blue Lagoon in Bath with Simone Ferracina. And we started the semester by asking students to develop one of the 3 model types in groups of 3 or 4. These are images of the final studio installation after they reworked the models over several weeks. We then asked students to develop fieldwork instruments that they tested first within the Blue Lagoon in Iceland, and then within Bath, UK. The significant element of both of those sites was the presence of geothermal activity, which raised interesting questions about what it means to design in a context of thermal surplus. So there were 3 ways in which the environmental models went on to inform design proposals in Bath. The first is by conceiving of buildings as environmental instruments, drawing on some of the insights about the instrumentation of the environmental models themselves. This was exemplified through Jamie Wilson's project, Rescripting Civic Performances. And his group started by developing a series of wind tunnels. They worked iteratively. So they developed a lot of prototypes and really became interested in all of the individual components and their roles in channeling and directing airflow. This went on to inform fieldwork instruments. They revisited the wind tunnels upon their return, used them to test airflow patterns through designs in Iceland, and developed a kind of strategy for cataloging all of those components and their roles. And then basically extrapolating some of those roles to develop designs for instrumental or instruments incorporated within the design of a building in Bath. So this is a section through Jamie's proposal, and I think the best example of that translation is a series of these sort of baffles that effectively carry and channel hot air from a subterranean thermal bath through the midsection of the building and up into a greenhouse section. So there's a kind of stratification in the building that mirrors thermal stratification, and there are architectural components that operate as instruments to facilitate airflow. The second way in which the environmental models informed architectural proposals was by enabling a kind of environmental immersion through photography of the models that captured certain kind of environmental effects that would be difficult to capture otherwise. And this is exemplified through Cherie Wong's project, Machinic Landscapes. So their group started by developing a water table, and they became quite interested in the kind of machinic language of that water table and the closed-loop water cycles that it perpetuated. And they used some of those logics then to develop a series of maps in Bath that looked at rainwater and wastewater strategies. They then applied this machinic language to the development of a series of different therapeutic facilities in Bath. Cherie's incorporated both algae cultivation and hydrotherapy. And the relevant point for this design was that she then used a series of physical models to try to visualize the kind of atmospheric qualities of the space she was designing. She resituated some of the details from the design into the environmental model and used strategic photography to give a sense of these sort of complex interplays between water, algae, and light. The third way in which the prototypes informed an approach to architecture was by acknowledging the kind of complex scalar realities of the environmental model, which can really be read across three scales: the scale of the architectural model in the testing bed, the scale of the one-to-one artifact of the model itself, and the scale of the kind of enigmatic scale of the environmental phenomena being simulated. So this multi-scalar capacity of the environmental model informed the work of Rennie, Haylock, and Sidwell in their project Inhabiting Infrastructure. They were really interested in material cycles and developing closed-loop systems, which opened up ways of thinking about larger territorial and infrastructural scale issues on site, both in Iceland, but also in Bath. They selected a series of sites of sort of infrastructural obsolescence to then design within at multiple scales. So Laura Haylock's project was cited in a social housing project, and she basically proposes a redensification of dwelling and the displacement of thermal activities such as cooking, bathing, and laundering into a collective community-wide facility. So the project operates at the scale of the region in the sense that there's an existing CHP facility within the building. She proposes a switchgrass conversion that is grown within a wider context of the site. The project is explored at the building scale in terms of all of these kind of complex thermal exchanges, as well as at the scale of the detail with these various sort of draped tectonics, and an architecture that's really as much about steam, condensation, and heat as it is about physical architectural materials. And she tested some of those profiles back in the filling tank, returning to the original intent of the environmental model as a mode of technical verification. So I'm just going to conclude with this image to suggest that there is a lot of value in using environmental models in this way for visualizing the general patterns of airflow. But what I've found through my own research and teaching is that by engaging with the challenge of actually prototyping the physical apparatus itself, a much wider range of issues related to environmental mediation emerge. Thank you very much.